Hi there, it's Nono here, and this is a short overview on how to convert Pix2Pix models to TensorFlow.js. This is a hands-on tutorial, and we're gonna get right in and see how we can get a H5 model from Keras format and convert it into a TensorFlow.js model that we can directly use on a Node.js app or on a web app. And we'll have a separate video to do that, to use it in Node.js and then to use it on the web. All right, so let's dive in and let's get our hands dirty with code. So as a summary of what we're going to do today to convert the model is we're going to grab an existing TensorFlow Core Pix2Pix model in the Keras H5 format. We're going to create a Python environment and install the TensorFlow.js_convert tool with Anaconda, and then we'll convert our model from Keras H5 file to TensorFlow.js. All right, to convert the model, we have it here. So this was trained on Colab notebook. I'm going to show that Colab notebook. This is this notebook. After we train, like here, you save the checkpoint, and the outcome of the training process is H5 file. So it's this checkpoint, which is a Keras model, as I mentioned before. And if you open it with a program like Netron, for instance, you can inspect the layers. You can see how the model looks and see all of its machine learning architecture. Right, so this is the architecture, and today the only thing we want to see here is it's like you can pass a batch of images that are 256 inside and RGB channels, so 3 channels. So we have our model, and that means that we've completed this first step. So we craft the model, and now we need to create a Conda environment with TensorFlow.js. We do conda create and then n, and then we specify a name. So this is going to be live 30 because this is live stream 30, but it would make sense to put something as TensorFlow.js if what you're going to have there is the TensorFlow.js converter. And we specify that we want to use Python, maybe Python 3.8 if that's compatible, and then IPy kernel. I think if you put the -y, you don't have to confirm when this tells you that about the things that are going to be installed. Otherwise, you will get here a prompt saying, do you really want to install all this stuff? And then when we finish, we need to make sure that we activate our Conda environment. We're going to get into an environment that only has Python 3.8 and IPy kernel. It doesn't have TensorFlow.js because we haven't installed it. You can see right here that we have this thing, and we're going to rewrite it. So we're going to do conda activate live 30. If we were to do conda mlist, we'll see that new environment that has been created. So it's listed here. And then now I always like to do this which pip3, which Python 3. And that way we know that we're actually using pip and Python from inside of the live 30 environment. So now we can safely do pip install TensorFlow.js. And this is going to install the TensorFlow.js package, and after that we'll be able to use the TensorFlow.js_converter, which is what we'll use to convert our models. So now when this resolves, we'll have TensorFlow.js available for us to use here. All right, so this is now set, and we've installed TensorFlow.js. We can now TensorFlow.js_converter, and then we can write on help. And we'll get some help about how to use the command, some of the arguments that we can specify, and the configuration. But for our purpose, we're just going to use this simple command, right? So we're just going to get TensorFlow.js converter. The input format is Keras because it's the H5 file format. Then we point to our H5 file, and then we put that the path to where we want to save our TensorFlow.js model. All right, so let's do TensorFlow.js_converter. We can now specify the input format, which is Keras, and then we can specify the input file, and then we specify the output there, which we can put on the very same folder here, and then we say edges to tulips TensorFlow.js, and then we press enter. And what this is going to do is it's going to load our model and then export it from the Keras format into the TensorFlow.js format. Seems like that's done. So let's cross our fingers and open that directory. And now what we have inside of that folder is a fully fledged model that has been exported into TensorFlow.js format. What you can see in here is a set of shards of binary information, and at the very bottom we have this model.json file. So that model.json file defines the model architecture, that thing that we saw inside of Netron, and the rest are the weights. So that's the information that the model has learned throughout the training process. Without that information, the model doesn't know how to generate the right outputs. But with those binary files, with those shards, it can load the model architecture and then load the data of how it has to behave when it processes new images, right? So we can right click here and click on format, and then we'll see all of this JSON file that contains the definition of the architecture of a Pix2Pix model. We can see here things that are familiar to us. So the batch input shape is what I said before, any size of a batch, which is none in Python if you're familiar, but we have to use null in JavaScript or JSON. And then we have 256 sided images with RGB channels, right? 3 channels for RGB. And this tells you what Keras version was used, the version of the TensorFlow.js converter, and many other things. So with this, we conclude the part of this tutorial, which was about how to convert Pix2Pix models from the TensorFlow.js Keras format, H5 file, to TensorFlow.js. Thanks so much for watching. It was Nono here, and I hope you enjoyed it. I'll see you next time.